We're now going to change the text within our app to the current temperature. We're going to get our layout, text view, so current temp, low temp, and high temp. We're going to get our temp, actually let's do this. We get the main temp and low temp and all that. Low temp. Temp. We're going to put these around parentheses. In quotes, not parentheses. Then we're going to put in that degree. Temp as well. Current temp. Now let's see. 3 should be different. There we go. We have our regular temp, we have our low, and we're high. We just put in high and low, and we're finished. So now we have our data on the screen, but we can do a little bit more to clean it up. The first thing, we're going to be using the present data function instead of doing it by hand here, because it's already there. There's one thing called width. What width does is if we put main in here, now what happens is we don't have to put main.temp, main.min, and main.max. It automatically does, it gives you main, and then you just have to do the, use the function. So now we don't have to do main.temp, main.min, and main.max. We're going to look at null safety now. So with null safety, it automatically creates a null check for you. For example, here, if response.body equals null, because of the double exclamation points, if that is null, it's going to act exactly like Java. It's just going to throw a null pointer exception and crash. We don't want that, so we want to use double exclamation points as little as possible. What we can use instead is question mark, which what question mark does, it automatically creates a null check for that. So it takes response and says, is body null? And if body is null, just make weather null. Now we have this thing for variables if they are null, so we put a question mark at the side of it indicating that weather might be null because body might be null. And now whenever we use weather, we have to put a question mark whenever we want to call a function within it, because weather might be null, main might be null as well. And if main is null, this would turn null. And now with main, since this might be null, we can't call a function with it being null. We have to handle that. We can alt right click on it, alt enter on it, and we can either surround it with a null check. And we can do that. It's 3 lines. It doesn't look very nice. It's in the way of everything. But we also have something, a non-null check. So that means I don't care if it's null, just do this. But if we do present data, it's going to give us, nulls across the entire app of the text, the max temp, and the min temp. We don't want nulls in there. We'd rather have just the past data than nulls. We're not going to do that. What we could do is let. What let does, I'll show you. We take main, and we see if main is null. Exactly that. Let me go back to it, and then see that we're taking main, and we're seeing if main is null. So if main is not null, run this. But if it is null, just skip it. So we will only do this if main is not null. That is null checking, null safety. We're now getting the zip code from our edit text and calling this function getting our weather. The first thing we need the zip code text, and we're adding, just like in Java, add text change listener. But this time we're just going to do the object again and text watcher. Now we're implement all of these. We're going to do after text. We're going to first rename this to code text. Just edit. Edit text tools. That, and we'll do if text dot length equals 5, which is the size of a valid zip code. And then we are going to call get weather from zip code. And we're just going to put in our text. We'll rename that to code. Code. Here, this is an int as well. Now we get to play and see if it works. Random, and something happened. Now you have to get rid of these to-dos every time. I'm not going to use them, so I'm just going to get rid of them. But it is nice to know that you do have functions here that you haven't used, and it actually prevents you from even running the app. So you actually have, you know that you didn't do a method right. Now if we put in a random zip code, done, and it automatically did it for us. We're going to be running our code with unit tests from now on to make this a little quicker. But we're going to be looking at list of and mutable list of to create lists. So go into test Java and then your package name and then just create a random class. I named my example and tester. We're just going to use this one class for everything for a few videos. So to create a regular list, we can do it shorthand with list of. We can create a list of ints, for example, and with list of, it's actually just a list and it's a generic type, so we can have int along any object we want. The downsides of a list are they're only readable. We can't change any of the information inside the list. So if we get list of index 0 plus and equals 1, we can't do that. It won't let us. There is no set method. All of the variables and indexes on here are all val. They're not var, so we can't change anything in here. But we can iterate over them. We can get in a for each and then print these out. We can print those. We'll have 1 through 4. But we also have something like a mutable list. Which mutable means we can edit it. So we have read and write access. We can take the first index and we can plus equals 20. And the first one will be 21 because we just changed it right here. We can also add big number. And we can also remove. But we can remove different ways. So we can remove by an element. So we can remove 3, and this will not remove the index 3, but the index with 3 in it. If we want to delete an index, then we just remove at, and that will remove the index of that value. And now index 1 is gone, the 21 not there anymore. And that's mutable lists and lists. How do we filter a list in Kotlin? Now I'm going to show you how to filter a list within Java first and then show you Kotlin. So in Java we would create another list. The mutable list of, and then put int. We would iterate over our mutable list. And then, if and put in our filter item is greater than 2, for example. And then do the mutable filter list. And then add our item. And that's how we do it in Java first. A lot of code right here. We have, 5 lines of code around. Now with Kotlin, we're taking our mutable and we're just putting filter on it. What this is doing exactly over here. So this is taking each item, and then we're going to see if item equals to 2, greater than 2, I mean, and this is going to give us our filtered mutable. It's going to give us the same exact result in only just 1 line of code. We're going to verify that it actually has those results that are greater than 2. We're going to do a for loop on it. To see what's inside of the list that we just filtered. Now we can see we have our list with 3, 4, and 5, which is greater than 2, and we can also do things like equals equals 2. We can change that as well. So in this sense, we would only get 2. We're now looking at count and also average. So with count, we can actually see how many of the items are within a certain filter. So if we filter into greater than 2, we'll see that we have 3. And I'll show you the Java version of it first, and then the Kotlin version of that. So first we would create a count of items. Create a mutable list of that, of an int. And we would take our mutable and then for each doing a for loop over our mutable list. And then if item is greater than 2, actually we don't need the count of items, we just need count. Zero, and just do count plus plus. Every time there is something that's greater than 2, we're going to increase our count, and we have to make that mutable so we can change that. Let's do it the Kotlin way, the easier way. We're just going to do mutable dot count, and we're going to put in our filter here, just like filter. We're going to do item greater than 2, and get our count of greater 2. And we can print that counts greater than 2 and really all of that, and that's a lot easier than the just regular doing the for loop and doing that. The mutable.count is a lot easier than doing a for loop, creating our own variable of count and adding to that. We can just do it this way with count of 3. We also have another one called average. This only works on, ints and doubles and float lists. That this won't work for, objects. We can do average on that, and we will get the average of all these numbers. Now we have our average. And to do this same thing, we would have to create another for loop and then another variable and then pretty much calculate the average that way. Am I doing that, 5 or 6 lines of code? This is 1 line of code. We see we have a null in this list. How do we get rid of that null? In a very easy way. Well, there's a function called filter not null that will get rid of these nulls for you, but I'm going to show you exactly what it does in Java before we do the Kotlin version. In Java, how this would be done, it would do a for each on it. We would have an item. Not exactly this, but this is a easier way with for each. Then we then create another list without nulls equals mutable list of, just a empty list, and that's an int list. Now if item doesn't equal null, we then add that to the list. List without nulls. I'm just going to add to that our item. That's exactly what the filter not null does. It's for loops over the entire list, says if this item is a null, put this into the another list, and then that's pretty much it. Now I'm going to do a filter not null in Kotlin. We're going to have filter not null, and that's it. We can see that it is pretty much the same thing as filter, except it's doing a filter is returning another list. So what we have to do is create another list called list without nulls. And we're going to do another assert that. Assert equals, and we're going to do a mutable list of with 1, 2, 3, and 6, and one with 1, 2, 3. I mean, the list without nulls, and we're going to see if that works. Now, when doing this, you could also do a regular filter, such as doing just a regular filter here, item, and do item does not equal null, and that would essentially be the same exact thing, but it will be more code to write. This does that for you, and we could see that we're looking at extension functions now. So extension functions are something that we can create, such as creating our own function for a class. For example, we can have people, so our immutable list, then add a average function exactly like this. Or we can have something like having a string and then creating another function like a fancy split that we have with lambda like this. We can do that. We can create lambdas with that. And we're going to do that really quick right now. The first thing we need to create the function. Second, we need to create the generic type. The generic type, I like to put T. And now, since mutable list is a list, if we go to that, and we go to mutable list, collection, we can see that it derives from iterable. So we have to put iterable as the class name. Now we are going to create a function from that class iterable, so it will work because it extends from iterable with people, which is a list. We're going to put average, and we're pretty much going to make exactly what it is. It's going to get the average of the age. We're going to take each age, average of all of them, and calling that we don't have that. We only have averages with just a list of numbers, not with object. So now we have our predicate. Now we have a parentheses, and what this is we put T there. What that means, we're giving predicate a type of T inside of a parentheses. This is saying that we want T, so person, inside of this this lambda of code. We want this type person. And we want this be an int. Okay? T, this parentheses is what we want this to return. And this is just what we want to in a simple case that's what that is. Now we are going to get the number of the size of our list first. Of items. Well, no, we can't do this dot size because it's not a list. It's a iterable. We're just going to do this dot count. Easy. Just count. We have the count of every item in there. Now we're going to get the sum of all of the items in there. Rate over them. Items. Now we're going to take predicate. So what we're doing is we're going to take predicate. What predicate is this. So with each item in here, we are going to say we want to call this function. So we're saying instead of predicate, we're doing under the hood, we're doing elements.age, for example. But we have to give that element to it, so we're going to pass in element. Predicate is pretty much just a pointer to this, and we're just pointing the data to our element. So this is just person.age. And Kotlin is telling us we have an easier way to do this. So we're going to listen. We have a sum by, which we can do that, and it does sum of exactly what we did before. We're going to return sum of items divided by number of items, and that should be our average. Return type. Print line of average string. Now we have our average. We can change this as well. We can add another person and put a for age goes down to 30. Now we know what extension function